when you do this in practice, number of questions that come up. So we talked about unigram models. Could you use higher order models, right? So could you use bigram models, or could you use maybe models based on parse trees or something like that? You could use different event spaces. So the event space that we went over is urns. So that's multinomial distributions. We could have used Bernoulli distributions in the same way that the classical model used Bernoulli distributions. So that's words absence or presence. You can't model frequency this way, but so once you decide on a model, how you estimate the model, and that we've pretty much covered. The whole lecture was on estimation methods. And then once you estimate it, it turns out that there is more than one way to rank things. So we've talked about ranking by query likelihood. So what is the probability of observing the query as a random sample from the document? But you could do a couple of other things. So you could compute KL divergence, say, between the query distribution and the document distribution, things like that. Okay. So a couple of words about unigram models. So as soon as this was developed, and this model is a lot more recent. This came out in '99. So as soon as it came out, people started trying to apply higher order language models in the hope that you would get better performance. So bigrams, trigrams, tree-based models. None of them work. So I touched upon the reasons why that might be the case. It's you're trying to solve a problem that doesn't really exist. So nobody really knows why it doesn't work. It's just the fact is there have been a lot of attempts and none of them have worked out. One possible reason is documents are already well formed. Queries are already written by users. You shouldn't waste probability mass on trying to put them in the right order. Especially because you're not going to get anything from that. You're just ranking documents. You're not trying to generate new streams of text. So it's kind of wasteful. Now you could ask, what about phrases? So shouldn't we use bigrams to model phrases? Bigrams are a horrible way to model phrases. What you're going to do is, if you do bigrams in this model, you're going to square your parameter space. Because now you're going to condition the word on a preceding word, and a preceding word has, it could be any word in the vocabulary. So now you're conditioning the current word on, 10 to the 7th possible previous states. So you're squaring your vocabulary. It's a horrible way to do this. You're never going to be able to estimate anything. There are better ways.